So as we did this question yesterday,
Yes,
Yes,
sir.
sir.
right?
So we have to do this.
Yeah, this is yes. Now, Nucilla Pelagiae from Samoa holds a Commonwealth Games record for weightlifting. Now, guys, does anyone know what is the meaning of Commonwealth? Yes, boys. Does anyone know what is the meaning of Commonwealth? Someone knows? Okay, let me tell you that you know that Britain, England, it ruled about all around the world. Only you see few countries were left where the Britain did not rule. Do you know this or not, boys?
Yes, sir.
Yes, sir.
Yes, sir. I know
See,
about.
even right, even it ruled on Pakistan, India, Bangladesh, right, and it ruled on you see Australia, New Zealand,
Yeah.
right? Now, all these countries which got independence from England, from United Kingdom, those countries, they are called as Commonwealth countries. Right, boys? Those countries, they are called as Commonwealth countries. Now, so there are, you
Okay.
see, special games about those countries which happen over there. So this is just, I wanted to give you an idea, right? Just like Olympics, there are games. So there is games between these Commonwealth countries as well. Now write a balanced chemical equation for anaerobic respiration in muscle.
Second it
Yes, son. I have taught
C6
you if you guys remember.
H12O6
Yes,
is makes 2C3H6O3.
very good. Right? I have taught you this, right?
Yes, sir.
Next one. Weightlifting involves contraction of the muscles of the arms. Figure 4.1 shows the muscles that move the forearm. Describe how the muscles identified in figure 4.1. Now, this is not in your syllabus, so we just leave it. Now, with this question, exercise that occurs over a longer period of time than weightlifting often involves aerobic respiration as well as anaerobic respiration. Means that when a person is exercising, maybe for 1 hour or 2 hours, so during that time, definitely the muscles, they will perform aerobic respiration, but there will be anaerobic respiration as well. Figure 4.2 shows the oxygen consumed by an athlete during and after a 5,000-meter race. Now, here is the oxygen consumption per cubic decimeter per minute on the y-axis, and this is the time per minute. Now, if you guys see that the exercise is starting at the 5th minute and this race is starting at the 5th minute and it is ending at about 16th minute, right? Can you guys see? This is the 16th minute over here. Now describe the athlete's oxygen consumption during and after the race as shown in figure 4.2. So you will tell from 5th minute up till you see this 16th minute, and then from 16th minute up till 35 minutes. So it is description. So what do we do in the description? We use the data, right? And we write down whatever we see. We see that where consumption is increasing, where it is decreasing. Right, boys? So who will tell, boys?
Can
Yes.
during the race from 5 to 10 minutes, the athlete's heartbeat rised. it, it rised straight, high, something like that. After 10 to till 15 minutes, it's rised a little bit, and from the 16th minute it stopped. After 16th
Listen,
minute,
listen. You are telling the time, but you are not telling about the amount of oxygen consumed. You also have to mention how much oxygen is consumed. Like you will tell at 5th minute, the oxygen consumption was 0.3, right? Cubic decimeter per minute. At, oh, you see which minute is this? If we come down over here, it is at 8th minute, the consumption of oxygen became 2 cubic decimeter per minute, right? And it steadily kept on increasing. And on the 16th minute, the oxygen consumption was 2.4 cubic decimeter per minute. Got it? So you use the values from both axes, from x-axis as well and from y-axis as well. All right?
okay, sir.
Okay.
Yes, sir.
Okay. Yes, continue.
After the race end, his breathing level start to decrease. On the 20th minute, the oxygen consumption was 1.3 cubic decimeter per minute. At 25, it was 0.4 cubic decimeter per minute, and from 30 to 35 minutes, it was 0.3 cubic decimeter per minute.
Very good. Very good. Now, next question. Explain why the oxygen consumption does not return immediately to the resting level after the exercise is finished. Now, boys, again, I told you, remember that the question about oxygen that can come for at least 4 marks and maximum 6 marks. So here he has asked the question for 5 marks, and the statement does not tell that he's asking about the oxygen debt, but actually this question is about what? It is about the oxygen debt. Why the breathing rate does not become normal after the exercise, right? Or in other words, here he is asking why the oxygen consumption is not returning to the normal right after the exercise. Okay, boys? Now who will answer? Yes, boys. Anyone? No one can answer this question. Okay, boys, listen. The answer is that as a person, he was exercising. So during that time, both aerobic and anaerobic respiration was going on in the muscles of that person. Now, during the anaerobic respiration, the lactic acid was produced, and this lactic acid, which is produced during the anaerobic respiration, is poisonous. So what happens that this lactic acid after the exercise is transferred from the muscles to the blood. Then what you will tell that the blood carries this lactic acid from the muscles towards the liver. Now in the liver, two things happen to the lactic acid. I have taught you that 3 out of 4 molecules will be converted back to glucose, and the energy will come from the respiration by the use of the oxygen that will be inhaled after the exercise. Second thing, boys, that 1 out of 4 molecules of lactic acid, they are broken down into carbon dioxide and water, and for breakdown of lactic acid into carbon dioxide and water, oxygen is required. Understood, everyone? So that is why as the oxygen is consumed after the exercise, right? Oxygen is consumed after the exercise. That is why it is, you see, the oxygen concentration or the consumption does not decrease right after the exercise, and it decreases slowly. Understood, everyone?
Yes, sir.
All right. Now, as this is the next worksheet, the liver is an organ with a large number of different functions. Figure 4.1 shows the liver, its blood supply, and some other organs. The blood vessels are labeled P to R. Now, what is the name of the blood vessel R, boys? Who will tell me?
Sir, sir, is it the hepatic portal vein?
boys, what is the name of the blood vessel R?
Sir, hepatic portal vein.
Very good. Hepatic portal vein. Okay. What do we call it? Hepatic portal vein.
Okay, sir.
And what is the name of the blood vessel P?
Sir, hepatic vein.
Very good. It is hepatic vein. Now, what is the name of the blood vessel Q? What is the name of the blood vessel Q? This blood vessel is going towards the liver, boys. Just think about it.
Aortic artery.
This is hepatic artery, right? This is taking the blood towards the liver, right? So this blood vessel is called as hepatic artery. Understood, everyone?
Yes, sir.
A person eats a meal containing protein and carbohydrates. Complete table 4.1 to show the blood vessel that has the highest concentration of glucose, oxygen, and urea as this meal is absorbed. Use the letter P, Q, or R to identify each blood vessel. Now, boys, which blood vessel has the highest concentration of glucose out of this P, Q, and R? Very good answer, because this blood vessel is coming directly from the small intestine, right? From the digestive system. So the R has the highest concentration of the glucose. Which blood vessel has the highest concentration of oxygen, boys?
Q.
Q.
Very good, Q, because this is the hepatic artery. It is the one which is bringing the blood from the heart to the liver. And which blood vessel has the highest content of the urea?
P.
P.
Very good. It is P, because P is the hepatic vein which is coming out of the liver. And you guys will learn inshallah in the grade 9 that you see this what happens, that breakdown of amino acids happen in the liver and urea is produced in the liver. All right, boys?
Okay, sir.
Okay, sir.
Okay. Now, next question is, amino acids are absorbed from the small intestine and transported to the liver. Describe how the liver is involved in the metabolism of amino acids. Inshallah, you will learn that in grade 9. Describe the effects on the liver of the following. Insulin released from the pancreas. Again, it will come in the grade. Adrenaline will come in grade 9. Excessive long-term consumption of alcohol will come in grade 9. Cholesterol can accumulate in the gallbladder to form gallstones. These gallstones may stop bile flowing from the liver through the bile duct and into the duodenum. Explain the possible effects of gallstones on the digestion of fat. Yes, boys, this question is from your syllabus. That he is saying that inside the gallbladder, sometimes because of higher contents of the cholesterol, the stones are formed. and these stones, they block the bile duct. And when the bile duct will be blocked, the bile will not be able to pass from the gallbladder to the duodenum. What will happen to the fat digestion? This is a 4 marks question, boys. Who will answer? Okay, boys, I'm giving you this question to think about, and in the next class, I will ask, inshallah, about this question. Time is over, right? So, see
Yes.
you guys, inshallah, in next class.
Yes.
Take care and
Uh,
Allah Hafiz.
Allah
Yeah,
Hafiz.
sir.
Allah Hafiz.
Allah Hafiz.